This meeting is being brought to you by the Fractal Center Point Labyrinth. All right, for today, we will go through 4.2 and 4.3 about, excuse me, there, about solving compound inequalities and solving inequalities involving equations and inequalities involving absolute values. Sorry. All right, let's begin. A compound inequality like this is a double inequality. A less than B. A is less than X is less than B. It means that A is less than X and X is less than B. This is called an open interval. It's everything between points A and B, but not including them. We denote that by these open circles. It can be thought of as this and means an intersection of half lines. Here's a half line of everything less than B. Here's a half line of everything greater than A. They intersect, they overlap in the open interval. We could also have two open half lines like this. X is less than A or B is less than X. I call this an anti-interval. It's everything except the points from A to B inclusive. So it's a union of two half lines. Usually we'll be talking about intervals. A less than B less than X less than B is an open interval. It's denoted by parent A, comma B, and parent, round brackets. If instead it had less than signs, you had less than or equal signs, A less than or equal to X and X less than or equal to B, this is a closed interval. It includes everything between A and B and also the endpoints A and B themselves. So we denote this with square brackets around the A and the B. Now you could have what are called half open intervals, I guess also half closed intervals, if one of the inequality signs is a strict inequality, less than, here or here, and the other is a less than or equal. So here you have everything greater than A and less than or equal to B. So you exclude A, you include B, and everything in between. Denote this by round bracket A to B square bracket. Here, less than A less than or equal to X less than B. We include A, not B, so we put the square bracket near the A. Okay, now, so here are some examples. 4 less than or equal to X plus 3 is less than or equal to 7. Now, the same rules we had last time still apply. Given an inequality, if you subtract 3 from all 3 parts in this case, the inequalities still apply. So 4 minus 3 is less than or equal to X, is less than or equal to 7 minus 3. So the 3 cancels, we're left with an X in between. At 1 less than or equal to X, less than or equal to 4. The closed interval from 1 to 4. Now here they ask to solve and graph. 3 plus 2 is less than 8, or 2x minus 3 is greater than 11. All right, now first to solve this, we subtract 2 from both sides. It keeps the inequality the same. 3x is less than 8 minus 2. 3x is less than 6. And then to divide by 3, a positive 3, dividing by a positive number keeps the inequality the same direction. X less than 2. But wait, or all this. Okay. 2x minus 3 is greater than 11. We add 3 to both sides. 2x is greater than 11 plus 3. 2x is greater than 14. Divide both sides by positive 2, which keeps the inequality the same. And so you get x is greater than 7. So it's this half line, x less than 2, union this half line, everything at least 7. So we denote this by minus infinity to 2 for this half line, union 7 to a positive infinity for this half line. This U means a union, which ultimately comes down to this word or. Now here we have 2.2x is less than 19.8 and negative 4x is less than 40. All right, here, for this one, we divide both sides by 2.2, a positive number, so the inequality stays the same. Get x less than negative 19.8 over 2.2, and OMG, I don't know how this, oh yeah, so there, oh dear. Oh dear, oh dear, oh dear. I'm gonna have to change this one. I blew this one. Oh my. I think we need a negative, well, I'm not sure how this happened. I think this should be a positive 19.8. Page 3, 2.2x is less than positive 19.8. Otherwise, it doesn't work. Okay, I'm sorry. This should be a positive 19.8. I will change that in the canvas after the class. All right, now going on to this, minus 4x is less than 40. Okay, here we divide by negative 4, and dividing by a negative number flips the inequality. X is greater than 40 over negative 4, so x is greater than negative 10. Okay, this should be a positive, this should be positive, and this is positive. So negative 10 is less than x, and x is less than 9. So it's the open interval from negative 10 to 9 after I fix this. How embarrassing. Okay, or maybe I should make this a negative 9, negative 9, negative 9, negative 9. Maybe that makes more sense. I'll have to change it in the canvas. Here we have negative 6 less than negative 3 times x plus minus 4 less than or equal to 24. Okay, this first step here is divide throughout by negative 3. And dividing by a negative flips a less than to a greater than, and a less than or equal to a greater than or equal. So you get negative 3 over negative 6 over negative 3, that's a 2, is greater than x minus 4, is greater than or equal to 24 over negative 3, which is negative 8. Now if we add 4 throughout, which again should keep things the same, then, hold on, then you get 2 plus 4 is less than x is greater than x is greater than or equal to negative 8 plus 4. Just a second. A lot of people seem to be falling in and out of the spot. This is ridiculous. So you get 6 greater than x is greater than or equal to negative 4. Now, I have to admit, I don't like greater than signs. I prefer less than signs because that way the numbers lie on the page in the same way they lie on the number line. But it's all right. If you have greater than signs, you simply write it in reverse. So 6 greater than x greater than or equal to negative 4. Flip everything backwards and get negative 4 less than or equal to x is less than 6. So it's a half open interval, including negative 4, excluding positive 6, square bracket, negative 4 to 6 round bracket. Here we have another or. This is true or this is true. X thirds minus x over 4 is greater than 1/6, or x halves plus x over 3 is less than or equal to 3/4. Now, all right, we have denominators 3, 4, and 6, 2, 3, and 4. In both cases, 12 is a common factor, common multiple, excuse me. So multiply throughout by positive 12. That keeps the inequality in the same direction. 12x over 3 minus 12x over 4 is greater than 12 over 6. Here, multiplying throughout by 12, again, it keeps the inequality the same. 12x over 2 plus 12x over 3 is less than or equal to 12 times 3 over 4. Now, after some reductions, this becomes 4x minus 3x is greater than 2. And this becomes 6x plus 4x is less than or equal to 9. We reduce this, it becomes x is greater than 2, fine. We reduce this, combine terms, 10x is less than or equal to 9. You divide by positive 10, you get the same inequality, same direction, and x is less than or equal to 9/10. So x is greater than 2, moving off to the right here, or x is less than or equal to 9/10, everything to the left, and including 9/10 here. So this is the graph. The interval notation is negative infinity to 9/10 square bracket, union, meaning or, round bracket 2 to positive infinity, meaning this half line. Here we have a square with side x, s, the perimeter is 4s, perimeter is how distance around, and the perimeter is between 128 and 192. So what about s? All right, fine. So you plug in 4s for perimeter. 128 is less than or equal to 4x, is less than or equal to 192. Divide throughout by 4, that keeps the inequalities the same because that's a positive 4. 128 over 4 is less than or equal to s, is less than or equal to 192 over 4, which means 32 is less than or equal to s, is less than or equal to 48. And that's the range of solutions. All right.